Hello and welcome back. So in this chapter, we will talk about sequences and infinite series. This chapter covers topics that lie at the foundation of calculus. The first task is to make a clear distinction between a sequence and an infinite series. A sequence is an ordered list of numbers A1, A2, A3, and so on, while an infinite series is a sum of those numbers. So A1 plus A2 plus A3. So you see, sequence is the list of ordered numbers. Infinite series is the sum of those numbers. Okay? So the idea of convergence to a limit is important for both sequences and series. But convergence is analyzed differently in the two cases that we will discuss in this section. Okay. So first thing, let's do an overview of sequence and series. So definition, you can see a sequence A sub n is an ordered list of number of the form A1, A2, A3 up to AN and continue to infinite. The sequence may be generated by a recurrence relation of the form A sub n plus 1 is equal to f of A sub n for n is equal to 1, 2, 3, and so on, where A1 is given. So the first term will always be given to you. So A1, A2, A3, those are called terms, okay? And a sequence A sub n is equal to Fn for n is equal to 1, 2, 3. So this is the sequence. So use the explicit form for A sub n is equal to 1 to infinity to write the first four terms of each sequence. Sketch a graph of this sequence. So again, for A, we can see if n is 1, that will give me my A1, which is what? 1 divided by 2 to the power of 1, which is 1 half. So that means A sub 1 is 1 half. And if n is 2, A sub 2 will be 1 divided by 2 square, which is 1 over 4. If n is 3, A sub 3 will be 1 divided by 2 to the power of 3, which is 1 over 8. If n is 4, A sub 4 will be 1 divided by 2 to the power of 4, which is 1 over 16. And this continue. These are the first four terms. So that means the first four term is what? 1 half, 1 over 4, 1 over 8, 1 over 16. But this will keep going. And if I'm asked to sketch, so I'm going to sketch my sequence right here. I'm going to use this to be 1, 2, 3, 4, 5, 6, and so on. This is N, and this is A sub N, which I will use 0.2, 0.4, 0.6, 0.8, 0.10. So our A sub N is 1/2, which is 0.5. So this is A sub N, which is 1/2. When A is 2, that is 1.4. 1.4 is so that's 0.25. That will be somewhere right here. A2, which is 1 divided by 4. A3 is 1 divided by 8, which is 1.25. One divided by 8. A4 is 1 divided by 16, which is 0.0625. We will have A5, A6, and so on. It will be getting close to 0. Same thing. Let's do B. Again, on B, we use our calculator, okay? If n is equal to 1, then A sub 1 will be -1 to the power of 1 times 1 divided by 1 squared plus 1, which is -1 divided by 2, which is -1/2, right? That is -1/2. And when n is 2, I'm going to go fast a little bit now. You know how to substitute. If n is 2, A sub 2 will be equal to, you substitute 2, we will get 2 divided by 5. When n is 3, A sub 3 would be -3 divided by 10. And finally, if n is 4, A sub 4 will be 4 divided by 17. So then we will see the first fourth term of this sequence will be -1/2, 2 divided by 5, -3 divided by 10, 4 divided by 17, and so on. So if I'm asked to sketch, we will sketch exactly the same way we did the other one. So First thing, I would sketch my number line. Only 2, 4, A sub n, 1, 2, 3, 4, 5, 6. And this is n. Let me put -0.2, -0.4. So we know negative 1/2 is -0.5. So this means my A1 will be right here, -1/2. A2 is 2 divided by 5, which is 0.4. So when n is 2, divided by 5. A3 is -3 divided by 10, which is -0.3. Then finally, A4 is 4 divided by 17, which is 0.23. And that's it. I can change the color so you can see well if you want. So this is my A2, A1, A3, and then A4. So let's move to the next example that we have. Use the recurrence relation. So this is the recurrence form, the recurrence relation for A sub n is equal to 1 to infinity, to write the first 4 terms of each sequence. So, in this case, A1 will, or a recurrence form A1 will always be given to you. So, which means we can find A2, A3, A4. So, first thing, between these two. So if n is equal to 1, that is given to us. We know A1 is equal to 1. So when n is equal to 2, we know based on the recurrence form, oh, sorry. When n is equal to 0, because in this case, that will become oh. So when n is equal to 2, that means this n will be 1, right? So we will have A2 will be what? 2A1 plus 1. Or we have A1 is 1. So that will be 2 times 1 plus 1. So A2 would be 3, right? And so on. So A3 would be equal to what? 2 times A2 plus 1, which will be what? 2 times 3 plus 1. So my A3 will be 2 times 3 is 6, 6 plus 1 is 7. Then finally, A4 will be equal to 2 times A3 plus 1, which will be 2 times 7 plus 1. So my A4 will be 2 times 7 is 14. 14 plus 1 is 15. So that means the first term of this sequence will be what? 1, 3, 7, 15, and so on. We are going to do the same thing with the second one. You can see when n is equal to 1, A1 is given to us as -1. But A2 will be equal to what? 2 times A1 plus 1, which will be 2 times -1 plus 1, which is -1. So A2 right? When n is 3, A3 also will be 2 times A2 plus 1, which is 2 times -1 plus 1, which is also -1. So A3 also will be equal to -1. And finally, n is 4. This is equivalent of A4 will be what? 2 times A3, which is 2 times -1 plus 1. So A4 also will be equal to -1. So this means the first four term of this sequence is what? -1, -1, -1, -1, and so on. So we see that the terms of the first sequence increase without bound, right? It increase without bound, while all terms of the second sequence are what? -1. So you can see the initial term of the sequence may determine the behavior of the entire sequence. Let's move to the next one. So on the next section, the sequence B sub n is given to us. Consider the following sequence. 1, find the next two terms of this sequence. 2, find a recurrence relation that generates this sequence. And 3, find an explicit formula for nth term of this sequence. So we are going to answer these 4 questions, okay? But we start with the first one. Solutions. So by looking at this term, each term is obtained by multiplying its precedent by 2, right? Like you can see, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 48 times 2 will be 72. So that's why, let me just write this one so you can see. So each term is obtained by multiplying its predecessor by 2. So since this is 48, so we know the next two terms are, we'll have 48 times 2, which is 96, and 96 times 2, which is 192. So the next two terms are 96 and 192. And 2, we are asked to write a recurrence relationship. So because each term is 2 times its precedent, so we will just said A sub n plus 1 is equal to 2 times A sub n. The first term is 3. You can start with 0, A sub 0 is 3. But in this case, I will set for my n to be 0, 1, 2, 3, and so on. So anyway, the first term is given, which is 3. Don't forget the recurrence relation, the first term is always known. And then the last question is, to obtain an explicit formula. So let me write first, explicit formula. We note that we know A sub 0 is what? 3, right? A sub 1 will be what? 2, 3 times 2 to the power of 1. And if we continue, you can see A sub 2 is what? 3 times 2 squared, and this will continue, right? So that's why in general, we will just said the explicit form will be A sub n is equal to 3 times 2 to the power of n, for n is equal to 0, 1, 2, 3, and so on. And that's it. Okay, so I hope you have idea about sequence. So definition limit of a sequence. Perhaps the most important question about a sequence is this. If you go further and further out in the sequence of like A sub 100, A sub 10,000, and so on, how do the terms of the sequence behave? Do they approach a specific number? And if so, what is that number? Or do they grow in magnitude without bound? Or do they wander around with or without a pattern? So, you need to always understand those behavior, and that is important on a sequence. So definition, if the term of a sequence A sub n approach a unique number L as n increases, if A sub n can be made arbitrarily close to L by taking n sufficiently large, then we say sufficiently limit of A sub n as n approaches to infinity is equal to L exists. And the sequence converges to L. If the term of the sequence do not approach a single number as n increases, the sequence has no limit and the sequence diverges. Okay, so let's go ahead and do these few examples quick. We have -1 to the power of n divided by n squared plus 1 as n is equal to 1 to infinity. They said write the first four terms of each sequence. If you believe the sequence converges, yes, make a conjunction about its limit. If the sequence appears to diverge, explain why. So again, I know you know how to find the first four terms, okay? So we have to know the first four terms of this. Let me write solution. I'm going to go a little bit faster, okay? The first four term, n is -1. We have -1 divided by 2, which is -1/2. If n is 2, we have 1 divided by 5. If n is 3, -1 divided by 10. N is 3, 4, 1 divided by 17. So this will keep going, right? So if we check, you can see the term decrease in magnitude and approach to what? Because even if you sketch, we'll see both term. The first one is -1/2. Let's make this one -0.5. But the next one is -1 divided by 10, which is close to 0. And 1 divided by 5, right? So let's say 1 divided by 5, which is so as I was explaining to you, just look, if you let me make a beautiful graph so you can see it's converged to 0. Do not mind. So let's say this is -0.5. -0.25. 0.25. 0.5. So we have A sub n, A sub 1. If n is 1, that's this point, -1/2. A sub 2 is 1 divided by 5, which is 0.2. But A sub 3 when n is 3 is negative 0.1, which is very close to 0, right? And A sub 4 is 1 divided by 17, which is 0.05, very close to 0. So do you see? If you follow this pattern, of course, the numbers change positive to negative, but they are all approaches to 0. Does that make sense to everyone? They are all approaching to 0. So that will be our conclusion, right? The limit appears to be what? 0. Let's continue with B. So with B, again, let me put my solution. So we know the first four term will be cosine n is 1 cosine of pi is negative 1, 2 pi is 1, 3 pi is negative 1, 4 pi is 1, and this will continue, right? So in this case, the term of the sequence alternate between negative 1 and 1 and never approach to a single value. Therefore, the sequence what converge, the limit does not exist, right? Because we cannot find the limit at infinity or anything. So again, because if you try to sketch this one, 1, 2, 3, 4, you have A sub 1 is negative 1, 1. We have A sub 1. We have n is 2, so A sub 2 is 1. N is 3, A sub 3 is negative 1. N is for A sub 4 is 1. So in this case, the limit does not exist. Right? This sequence diverges, okay? And finally, C, same thing. Again, I'm going to go fast. We know solution. The first term is given, which is 1. The second term would be negative 2, 4, negative 8, and so on. Again, we can see This also diverges. Why? Because the magnitude increase without bound, right? So again, because the magnitude of the terms increase without bound, the sequence diverge. Okay? So now let's move on to infinite series. Okay? I hope you have ideas about sequence now. So, um, definition, infinite series. Given, give me 1 second. Okay, given a sequence a sub 1, a sub 2, a sub 3, and so on, the sum of its term a1 plus a2 plus a3 plus and so on is equal to, this is the summation formula, for symbol, which is also called sigma in Greek. A sub k, k starting from 1 to infinity, is called an infinite series. The sequence of the partial sum S sub n associated with this series has terms. So S1 is equal to A1. S2 is what? A1 plus A2. S3 is A1 plus A2 plus A3. And up to Sn, which is A1 plus A2 plus A3 plus, so up to plus A sub n is equal to the sum of A sub k from k is equal to 1 to infinity. So you need to know on the summation, A k is the lower index. So that means we start from k is equal to 1 and infinity is the upper index. That means we sum up to infinity. Okay? So if the sequence of partial sum S sub n has a limit L, we said the infinite series converges to that limit. And we write the sum of A sub k from k is equal to 1 to infinity is equal to the limit of the sum of A sub k from k is equal to 1 to infinity as n approaches to infinity. If that limit give me L. If the sequence of partial sum diverges, the infinite series also diverges. So let's go ahead and do work on the first few examples, okay? So A, this summation is given to us. We are given the sum of A, the sum of 1 divided by k plus divided by k times k plus 1 from k is equal to 1 to infinity. A, find the first four term of the sequence of the partial sum. So the first four term, again, let me write my solution. So A, the first fourth term of the sum, so can be written as what? S1 will be equal to the sum 1 divided by k times k plus 1, k from 1 to 1. So it's just 1. So that would give us 1/2, right? Because k is 1. If you substitute 1, this is what you would exactly get. S2, which would be the sum 1 divided by k times k plus 1, k starting from 1 to 2 would be equal to, because if you substitute 1, let me do it by hand so you can see, you will have what? 1 times 1 plus 1 plus 1 divided by 2 times 2 plus 1, which would be 1/2 plus 1/6. That will give us 2/3, right? S3, which would be, so again, from now on, we already know S1, S2, right? So we know that will be k is 1, 2, 3 by k times k plus 1. So we substitute 1 for k, that will give us 1/2. Or we have already find S of 2, which is what? 1/6, so plus 1/6. Now plus, if you substitute 3, 3 plus 1 is 4, times 3 is 12, so plus 1/12, which is 3/4. And finally, S4 would be the sum k starting from 1 to 4, 1 divided by k times k plus 1, which would be 1/2 plus 1/6 plus 1/12 plus, when is 4, 4 plus 1 is 5, 5 times 4 is 20, 1 divided by 20, which will be 4 divided by 5. So B, we are asked, these are the first four terms. B, find an expression for Sn and make a conjunction about the value of this series. So if we check this pattern, right? B, so B, so based on the pattern, in the sequence of partial sum, reasonable, because the pattern said what? We have 1/2, then we have 2 divided by 3, then we have 3 divided by 4, then we have 4 divided by 5, right? What do you think the next one will be? I believe the next one will be just 5 divided by 6 and so on, right? So we can say what? Our S sub n is what? N divided by n plus 1, because the denominator is always just 1 unit more than the numerator. And I will set my n is start from 1, 2, 3, and so on, right? So a reasonable conjunction that, so we can find the limit. So the limit of S sub n as n approaches to infinity, which would be equal to, so don't forget, sorry, this is S sub n. My S look like 5. Don't mind me. Is equal to the limit of n divided by n plus 1 as n approaches to infinity, which is 1. So this means what? Converge, right? So this means this series converge. So this is a summary of what we just learned. Read and get familiar to it. So this is the difference between function and sequence and series. So n is, on the function, n is the variable. On the sequence and series, n is just your independent variable. And the dependent variable is a sub n on the series and sequence, but function is f of x and so on, okay? Okay, I will see you in the next